All right, classifying a triangle or using triangle classification theorems. We want to be able to, at the end of this, to classify a triangle using the converse of the Pythagorean theorem and the triangle inequality theorem. We want to be able to apply the converse of the Pythagorean theorem and triangle inequality theorems to solve problems and then to determine an unknown side length or range of side lengths of a triangle given its classification. Okay, well, first let's think here where we have the converse of the Pythagorean theorem. All right, the Pythagorean theorem, I hope that you guys do recall what that is. That is when we have a squared plus b squared, and that equals c squared, and that is when we are dealing with a right triangle, okay? And let's see as we go through the Pythagorean theorem. So a squared plus b squared equals c squared. And that, again, is when we deal with a right triangle. And in this case, we would see something along the lines of C, A, B, and then those would be my angles. And then my side lengths would be little c, little b, little a, and then that's where we end up getting that formula for. This would be the a squared, the b squared, and the c squared. And, you've actually seen the Pythagorean theorem for years now, and it was, consciously identified as those characters because we knew that our triangle, our angles were the large letters and our side lengths were going to be the small letters. Now, it also talked about the converse. Well, if a squared plus b squared equals c squared, they're saying that one side squared plus the other side squared equals the hypotenuse squared. Well, if you have a right triangle and you square the hypotenuse and then you square the other two sides, it equals the other two sides, then, if the square of one side of the triangle is equal to the sum of the squares of the other two sides, right? The square of one side of the triangle is equal to the sum of the squares of the other two sides, then that triangle is a right triangle. So if a squared plus b squared equals c squared, that's using the Pythagorean theorem and it's a right triangle. And then if this equals this, that would be my converse version of it though. And we're going for equality. So when using the Pythagorean theorem, we have which sets of numbers can represent the side lengths of a right triangle. Okay, so here we are. Which sets of numbers? Well, we know that when we are looking at a triangle, the longest side is going to be the hypotenuse. So when I'm looking at these possible side lengths, I know that the longest length will be the hypotenuse. And I have them in order. So when it goes from smallest to largest, smallest to largest. So the third number here should be the hypotenuse if it is a right triangle. And you can just fill everything in. So if we just do one quick diagram, right? So I have a squared plus b squared equals c squared. So that would be let's get that out of the way, right? So this would be my A, this would be my B, my C. So that would be a squared plus b squared equals c squared. And so do we have, and again, that would be 64 plus 144 is going to be equal to 225. And that does not equal 225, right? This is going to be 208 equals 225. So this is not going to be a right triangle. And we can just keep plugging those in again using A, B, and C. A and B are interchangeable, but C would be my longest side. So I'm going to have a squared plus b squared equals c squared, and we end up with 100 plus. So we end up with 100 plus 576 equals 676, and that would be the case because 100 plus 576 is going to equal that. So hey, we could say that those sets of numbers represent a right triangle. And again, 12 squared plus 20 squared is equal to 25 squared. And we have 144 is equal to, sorry, not equal to, plus 400 is going to be equal to 625. And that is not the case, so this is not going to be used for the Pythagorean theorem. Then I have 9 squared plus 12 squared equals 15 squared. And that is going to be 81 plus 144 equals 225. And that is the case. So there we go. We have another Pythagorean triple, three sides that are a right triangle. And then we have 15 squared plus 18 squared equals 20 squared. So that's 225 plus, I don't remember 18 squared off the top of my head. 324 is going to be equal to 400. And that does not look like that's correct, right? Because these are not going to equal 400. So that is not going to be used for the Pythagorean theorem. And that's how I can figure out if something is a right triangle, just by plugging in my three side lengths into my little formula here, which we've been working with for years to see if it's going to work. Now, when it comes to acute triangle inequality, well, it tells me that I'm not going to have a right triangle. Acute triangle means that my angle is going to be less than, all my angles are going to be less than 90 degrees. So an acute triangle, because the sides end up becoming larger than the hypotenuse, or what would be the hypotenuse, because as A and B overpower C, it becomes smaller. And we'll talk about the obtuse triangle inequality where, so maybe it ends up doing that, and that would be obtuse, and we'll do that example here in a minute. But as long as my values, if these two sides, the squares of these two sides added together are greater than C, then we have acute triangles. So here we have an acute triangle, has sides measuring 10 centimeters. All right, so I got this triangle right here. I don't know if it's a right triangle. And I have one side that is 10 centimeters, another side that is 16 centimeters, and the length of the third side is unknown. What are the possible range of the third side? Okay, the possible range of the third side. Now, this third side could be C, it could be B, or it could be A. We don't know. So that's why, as a range, what could it be? Well, first of all, we're going to go ahead and say that it's C. So then I would just go ahead and say, hey, this is A, this is B, and this is going to be my C side. So I have, again, A squared plus B squared is greater than C squared. So A squared is going to be 10. 10 squared plus 16 squared is greater than C squared. So we have 100 plus 16 squared. Don't remember it offhand. 256 is greater than C squared. So we have 356 is greater than C squared. And I'm going to go ahead and find the square root of both sides so I can figure out what the heck that side length is, right? So C, the square root of 356 is going to be roughly 18.9, okay? So that is one option. It could be 18.9. Now, if it turns out that that is not if the longest side happens to be 16, right? What happens if 16 happens to be the longest side? Well, that would then change the order here. So if I have 16, I have 10, and then x. Well, 10 we'll still call A, we'll call x B, and then 16 is now going to be my C. So I end up again with not big A, right? We have little a for a reason. A squared plus B squared is greater than C squared. So A squared, we would have 10 squared plus B squared is greater than C squared, which we said was 256. I'm going to go ahead and minus this 100 from both sides. So B squared is greater than 156. Go ahead and do the square root of that, and B is going to be greater than, let's see, what is the square root of 156? Looks like it is going to be 12.4. So the side length, right, whatever that side length is, could be it's going to be less than 18.9, but it's going to be greater than 12.4. And that would be my range of possibilities, because that missing side could be the hypotenuse, the longest side, or that could be not the longest side. So that's how we're able to figure that out. And when we use the obtuse inequality, right, we're saying that that third longest side is going to overpower the two shorter sides. So when the two shorter sides are less than that other one squared, so it says the longest side of an obtuse triangle measures 20 centimeters. Well, I'm just going to draw this exaggerated obtuse triangle because this right here is going to be greater than 90. And they said the longest side is going to be 20 centimeters, and the two shorter sides measures x and 3x, right? Bam, bam, bam. Got that out of that word problem there. And it says, what is the greatest possible value of x? All right, well, we can just plug it in. Call this A, call this B, call this C, using my formula. So again, A we said was 3x squared plus B, and B is going to go ahead and be x squared is going to be less than 20 squared. So this turns out to be 9x squared plus x squared is less than 400. And we're going to end up with 10x squared is less than 400. I'm going to divide both sides by 10. And x squared is going to be not equal to, but less than 40. I'm going to find the square root of both sides. And then x is going to be less than, I probably have this written down somewhere, but the square root of 40 is probably like 3.6. Let's see. Square root of 40 is, no, not 3.6, 6.3, sorry. 6.3 approximately. So there you have it. That what is the possible greatest value of x? How about it's got to be less than 6.3? And there you go. We were able to use the Pythagorean theorem, the acute triangle inequality, and the obtuse triangle inequality theorems to figure out how they fit into classifications. And let's see here. What classification represents the triangle with the side lengths of this? I don't know. Let's see. We have a squared and b squared. And then c squared. Well, if I have 36 plus 100, and then I have 144, well, 144 is going to be greater than that, so I think that means that is obtuse. And then if I have 5 squared plus 12 squared, and then I also have 13 squared, that's going to be 25 plus 144, and then over here I'm going to have 169, and I think this is going to equal 169. Well, if 169 equals 169, then we know that that is going to be a right triangle. So we're just able to use some of that information to verify our triangle classifications.